My name is Lisa Phillips, and I'll be talking to you about MySQL at Twitter. So not beauty and retail in case you need to go somewhere else. So you're all here mostly, I'm sure you all are familiar with Twitter, but who here tweets? Who reads Twitter? Yeah, so there's usually a lot more people who are consuming Twitter than are tweeting, which is fine. And from an infrastructure perspective, it's about the same to us because we still have to manage all the capacity to serve the tweets to you. So I'm going to start with a video displaying some ways that people are using Twitter data. But if there's one thing that I want you to get out of this conference today, it's to understand that despite some of the sexy big data terms that are being used out there, Twitter still uses MySQL as its primary data storage for most of its infrastructure. And I'll be talking about why we choose to do that and why we continue to do it and some of the ways we've had to work around MySQL. And I'm going to talk for about 30 minutes, and we'll do some Q&A afterwards. So a video.
An important part of public health is really figuring out your population. And Twitter opens a whole new window in a way to view that population and understand what's going on.
If you look at any individual tweet, you can't get that much out of it. But what we found is when you aggregate millions and millions of these, then they sort of form this big picture that we can actually use.
So in this study, we looked at Twitter to see what we could learn about public health. We took about 2 billion tweets, and we just needed to find which of those tweets actually was relevant to health.
Lots of people on Twitter have what we call Justin Bieber fever. So just looking for fever doesn't really work. We use what's called machine learning, and we actually trained a system to learn the difference between tweets that are about health and tweets that are not relevant to what we're doing.
Using that program, we were able to find out of those 2 billion, 1.5 million tweets that said something about health. The first thing we looked at was, can we use these tweets as a way of predicting how disease is going to spread in the United States and how it's going to change over time? And it turns out by looking at government data and comparing it to Twitter, we showed that we can actually do a good job.
It's exciting to think about what potential is there to improve our research, our understanding of health. And this is the kind of stuff we hope we can really tell some story that maybe wasn't obvious using traditional methods.
This really opens up the path for so many new types of questions. Stuff that we could ask before, but we couldn't ask well, and things that we couldn't even ask before. This really could change the way we do public health in this country and how we get feedback from our population.
So that's one of many, many, many stories that I hear on a weekly basis. And having worked for Twitter for 3 years, and I've been on call for most of those 3 years, it's stories like this that make it interesting to me and worthwhile to get up in the middle of the night and keep the tweets flowing as a part of the MySQL DBA team, because without the sort of the storage infrastructure, there's no sort of data or applications that we can develop on top of it. Another example and other videos that are out there are Twitter's impact to the MENA region, and how I met some women who told me that when Twitter was down, they weren't able to find out which parts of their area were safe to go out at night during the uprising. So for me, working for Twitter and ensuring that the tweets are flowing no matter what is about all the ways that Twitter can impact the world globally. And that there's a lot of value out of Twitter even if you are not particularly tweeting yourself, or even if you're tweeting about what you had for breakfast that day. So some stats about Twitter. We currently have 140 million active users that we're reporting right now. And just to give you some perspective, when I started 3 years ago, we didn't track active users. But the registered users in 2010 were, sorry, I missed that. Registered users in 2010, actually I don't even have that, I'm sorry, I apologize. We don't even know, I went back and looked last night. I was like, I can't figure out how many users, it was not that many. However, right now we're tracking 400 million tweets per day, and in 2010 it was 32 million tweets per day. So also in 2010, to give you some perspective, I don't know if you guys were around back then using Twitter, but the fail whale was something that we were known by. And when I started working at Twitter, you know, my friends gave me the advice, you know, they were like, I don't know why you'd want to go work there when it's just a fail whale all the time. Whereas today, we're able to sustain these, well, an average right now of 4,629 tweets per second. And back then, our tweets per second, when Michael Jackson died in 2009, that was our previous peak record, and it was 429 tweets per second. And that took the site down. So just a year later, when I started, again, we weren't tracking our averages, so I don't know, but it was not this high. Our current record right now is 25,000 tweets per second, and that was during a broadcast of Castle in the Sky in Japan, which was a popular show. I've never watched it. So our tweets per second record right now hasn't been broken, but what that means is, and what we know is that we're able to go from our average of 4,000 tweets per second up to that kind of a peak capability, knowing that our infrastructure can handle it. There were debates on a couple weeks ago, and this graph actually, it's hard to see, but we're tracking tweets per minute, which is something that our communication team often talks about, but to be honest, I don't ever track tweets per minute, because then I have to do the math and see what that works out in seconds. But this, I think it's like 110,000 tweets per minute at a peak, which is, what is that? A couple thousand tweets per second. So during the debates, our couple thousand tweets per second, in addition to regular traffic, is something that a couple years ago we wouldn't have been able to handle at all. So just going back for a minute, my own personal history, my handle's Lisa Phillips. I actually started out, well, in Seattle, I started out at Speakeasy, if any of you guys were around at the cafe, yeah. And, but then moved on to LiveJournal, and LiveJournal is actually where it was my first experience with social media and how open source technologies are vital toward their success, because social media tends to have not a lot of money, commodity hardware that frequently breaks, passionate users who will let you know how upset they are when the site does break, and so an expectation that your site's going to be up all the time, regardless of whether or not you're taking any revenue. So at LiveJournal, we developed Memcache, MogulFS, some other distributed storage platforms, and also we developed the sharding architecture that was used by Facebook and actually Twitter. So when I first started working at Twitter, we were using the same database, the same type of database architecture that LiveJournal developed in the early 2000s. So to give you an idea about how some of that, why we use the sharding techniques that we do, a lot of it came out of the LiveJournal experience. So I'm a lead with the MySQL DBA team right now. We are actually, just until recently, just 6 full-time database administrators. And when I say DBAs, we're not just people who do schema reviews. We get hardware without an operating system from our data center team. And our team of 6 DBAs is responsible for installing and management of everything above the hardware layer, from MySQL itself, the operating system, all the software we run on it. We have thousands of MySQL databases. So actually I just found out that per admin, our MySQL DBAs manage more servers than any other admin working at Twitter. So what I'm going to be talking about today is essentially how it is that we are able to manage that many servers to keep Twitter up, and some of the engineering philosophies that work in conjunction with the database philosophies, as well as what we've done on top of MySQL. Also, we're hiring, by the way. So even though I'm saying we're doing this awesome job, like, I would like to not be on call as often. So if you or anyone you know is a DBA, please come talk to me. We're hiring in Seattle, too. So today we're going to talk about engineering, we're going to be talking about MySQL, we're going to be talking about the past, we're going to talk about what we want to do in the future, some of the monitoring techniques that we use, and then I'm open to your questions. I might do choose your own adventure talk, actually, at some point, and see which way you want to go. So engineering at Twitter, we have, Twitter as a company has 1,300 employees around the world. 1,000 of them are in the San Francisco headquarters, and then we've got offices. I can't even keep track of all of our offices around the world, so we've got a lot. 50% of our employees are engineers, so it's a strong engineering culture and environment, despite the fact that, you know, on the front end, it doesn't seem like it would be that complicated to deliver tweets. The general philosophy that engineers have in our organization that's allowed us to scale the way that we have is that, in general, use commodity software and hardware. So our data center is full of servers that are the same as probably the rest of you guys right now. We don't have any kind of fancy hardware that, you know, I get calls about every single day. We have the same kind of stuff you can buy from the major vendors. And we build with an understanding that we should be able to tolerate some amount of failure, but still keep tweets going. So there's the best tool for the job, as everyone says. We use MySQL where it works, and then where it hasn't worked, we've tried to build around it. But I'll highlight the ways in which MySQL works in ways that people tend to overlook when they want to build the next new technology. Another major component to the reason that Twitter can conserve the number of tweets that it can is that we have the idea of eventually consistent all across the board, also utilization of queues. So when you tweet, even if it's 1 second delayed to your friends, most likely it's not going to be a huge deal. And that 1 second of extra latency on our side, and I don't mean latency from the website performance, I mean the tweet delivery. So you tweet when that gets delivered to all of your friends, means that we're able to sustain those kinds of peaks that I was just talking about without necessarily taking the entire site down. So the data that we take into Twitter, we use queues where we can at every layer. So we're using queues in our storage layer, we're using queues at the front end. Some of those, if you want to look this up later, there's, I believe it's open source, Kestrel is one of the technologies that Twitter uses for that queuing. Eventual consistency is another important part of the way that we store tweets. So it's important that we have your tweets and we don't lose them, and that's important to you as users, and it's important to us as well as a company. But like I said, it's not as important that you see that tweet within 1 second. So let's make sure the data is there and it doesn't get corrupt and it doesn't go anywhere. However, the time in which that happens is not as important as the fact that it remains there. So some of the parts that you see about new technologies, like new NoSQL technologies, a lot of that has to do with speed and performance, which is important, but you have to think about where is it important and where can you trade off something being eventually consistent, but consistent versus just fast. Another important aspect, we do actually several deploys a week at Twitter. So we don't roll back very often, and the idea is, actually, we were doing deploys every day up until recently. So as a DBA, again, we've only got 6 DBA, we have thousands of databases, and we're deploying code a couple times a day. There's not time for us to do schema review. There's not time for us to have rollback plans for every deploy that we do. And to be honest, as users, you guys wouldn't like it if we did that. You would see a lot more bugs not rolled back very quickly, because what we do instead is do soft launches. So every time we launch a feature, we launch it disabled. And then we have a decider key, it's called decider for us, that controls what percentage of traffic receives that. So sometimes this means that you see features before other people. So if you ever see that happens, that's what's going on. So from a DBA perspective, what we can do is watch the backend databases and say, is this actually causing performance degradation from our perspective before our users notice, hopefully. The other thing that Decider lets us do is to turn on some, 1% of traffic, measure the performance. If it is causing problems, then we will continue forward. We'll iterate and improve upon that until we turn up more of the traffic. So most of the fear, I think, that DBAs have when we do new features, and I've seen this across many companies, is that when a new feature is developed, we won't know the impact on the databases. And if you're a DBA, I'm sure you understand that fear. You know, like suddenly we're going to allow X Factor to DM votes for their favorite candidate or whatever the contestant. So that's scary for me as a DBA if I think that suddenly everyone's going to be using our DM infrastructure. And to be honest, I haven't measured whether or not the DMs could actually possibly handle that much traffic. And I'm not going to be able to. So something like a decider feature allows us to do some of those soft tests with live traffic before we turn it on all the way. So MySQL at Twitter. There's rumors out there that we use Cassandra, Hadoop, Vertica, that we've built our own technologies, and actually all of those are true. But again, when it comes to tweets, our follower graph, the metadata that that's associated with a tweet, so who your friends are, who you follow, who follows you, how many times you've tweeted, all of that data is stored in MySQL. And I'm going to talk about those rates in a second. Why do we use MySQL? In general, it's pretty fast. It's not the fastest thing out there, but like I said, when you've got a programming philosophy, when your engineers understand that you can use coupling, loose coupling, queues, you get some trade-offs. It doesn't have to be the fastest. Because in the case of MySQL, we know that our data is safe. And I'm saying that because MySQL has actually been around forever. We use InnoDB specifically, by the way. So this is for InnoDB, don't quote me on MySQL. But in the last 3 years that I've been there for Twitter, I actually can't really recall any data corruption issues we've had as a result of InnoDB. Because InnoDB and MySQL is so prevalent and has been around for so long, it's easy for us to find very sort of high-end engineers who have experience with running MySQL. So we know that it works. We know that replication generally works, and we know the ways in which it doesn't work. So, which is also really important. When you roll out a new technology, you may have all these awesome features that you're expecting, but if you don't know the ways in which it's going to work, and you're talking about data, there's less room for you to play with that because none of you guys would want it if your tweets went away. The fact is that MySQL has been around since almost as long as I've been around, I think, in technology, so it's been quite a while. So during that time, we have like a lot of operational tools. We've got Percona toolkit that we use a lot actually in our infrastructure. Google's building their own MySQL features. Facebook is as well. And actually we are as well. So there's a lot of involvement from the community with other sites like Twitter, but at the same time there's a lot of involvement from smaller sites. So if you're a small site and you're not sure, should I use MySQL versus something else, Couch database, MongoDB, whatever people are talking about right now, obviously that's up to you, but if you want to ensure that your data is secure and that you're going to be able to hire admins who know how to run it, then you may want to consider MySQL. What else do we say? Oh yeah, we value stability and performance, as I've just been talking about. So there are some reasons not to use MySQL. We have learned the hard way that MySQL is really bad at ID generation, and we've been bitten a couple of times with auto-increment issues as Twitter started scaling up, and I'll talk about that in a sec. The other ways that MySQL is not great at scale is when you're talking about a graph, especially as like user graphs. So MySQL is pretty good at saying, I follow Jamie, but it's not very good at saying, I follow, or Justin Bieber is followed by millions of people. So that lookup is costly in MySQL, and so we've had to develop an extra indexing technology basically in front of it. So again, if you're a smaller site, you can get away with it if you do one-to-one mapping. But if you're doing one-to-many, that's a way that you may not want to use MySQL for that. Replication, even though we said it generally works and we know the ways it doesn't work, it's actually really inefficient for MySQL. So if you were tuning MySQL just for performance, you'd actually want to remove all the replication features. It's heavy on I/O, it's heavy on disk, and when you're troubleshooting, performance issues related to MySQL, you've always got to keep in mind that it may be related to replication itself in terms of how are you writing your bin logs, how are you reading your bin logs. Actually, just a show of hands, who here is very familiar with MySQL before I keep digging into it? Okay, not as many as I hoped. That's fine. I just won't go into that much detail. See, it's choose your own adventure. This is actually the first time MySQL at Twitter has been talked about at a non-MySQL conference. So this is good for me to know what's actually interesting to you guys. Details are good. I just don't know how many details to go into. So MySQL replication uses log files, right, to sort of document all the statements. We use statement and row-based replication depending on the cluster. So when you have high-performance databases that are also highly available and you've got them clustered and you're not using NDB cluster, you want to, MySQL replication basically will, you'll have not only the database executing the SQL statements, the updates, the inserts, the deletes, you also have the clients reading from the SQL server, and in addition, it's got this sort of I/O thread that's got to be pulling log files from the master. So one of the problems with, and I'll talk about this in a second, but one of the problems with scaling MySQL with replication is that at some point your slave servers are no longer, they become a bottleneck because they're doing as much work as the master, and they're doing a lot of the extra work with reads to your slave servers. So we've actually architected around that a bit, and I'll talk about that. So when should you use MySQL? Basically, with any project at Twitter, when they know that when an engineer knows that they need to use storage, we ask them, you know, what's your tolerance for the service to go down? I mean, that should be your first question, no matter what, when you're rolling out MySQL, because it'll dictate what kind of a configuration you have. So we do have some services that they could be down for a couple of hours. These are peripheral services, or like internal services where it's just users internally and it's nothing externally facing. And in those cases, we don't need to spend a lot of time working on the most highly available solution for them. So what we do is we concentrate in the areas where there's no way that customers could stand for the service to be down, and save some of our cycles for, to allow some of those other services to be down. That's the reason, again, to go back to that we can have 6 DBAs. If every service, we have hundreds of applications at Twitter, and if every service required that the databases were available 100% of the time to milliseconds in latency, then we would have a much larger team managing those databases. The other thing is smaller data sets. So I'm talking about data sets. We'll talk about our data set size in a minute, but we're measuring it in terms of terabytes. That's maybe where you're starting to get into some limits of MySQL. But if you're a couple hundred gigs or something like that, there's no reason that you should be looking at scaling your application now, because you don't actually, unless you can anticipate what your data rate is and your growth, you may be optimizing for something that is not required and then getting yourself in trouble with regard to operational tools. Again, if you want to have your data live permanently, I think you should put it in MySQL. Some of the other technologies, until they're proven, are, the same argument could be made for Oracle, by the way, so I'm not anti-Oracle. But in this case, when you're comparing it to other open source technologies, if you can never tolerate data corruption, InnoDB is, in my opinion, the best solution for you. The other thing is there's some bugs with MySQL 5.0, 5.1, which I'll talk about in a second, that Twitter still encounters because we actually still have some of those living in our infrastructure. But with 5.5 and 5.6, there have been some major improvements that if you were rolling out MySQL right now, I'd definitely start with that, with 5.5. So DBA and engineering and how we can get along. So are any of you guys familiar with the idea that programmers and database administrators sometimes have tension? Anyone? Yeah. So, I mean, I know that DBAs are considered like eccentric and perhaps a little grumpy. And I mean, I have a systems administration background, so that's actually saying a lot. Like I'm saying, compared to a sysadmin, even DBAs are grumpier. And the flip side is I understand as a developer, you may not always realize what the value is of having somebody who's sitting there just understanding how MySQL works or just understanding how data works. So we have that healthy tension at Twitter. And to be honest, like I mentioned earlier, in a way, we kind of have to let go. Our DBAs trust that our developers are doing their best, and then we put the controls in place so that when they aren't, we'll see it, and we can respond quickly, and then hopefully make them feel a little more cautious for the next time that they want to develop something that has the potential to destroy data. What doesn't help, though, is for us to get really mad all the time and tell people no. Our DBA culture is to let people know that, you know, you're going to do something with data, we should be helping you with it, and not in your way. So in your own environments, I would encourage you to reach out to your DBAs early, because that always helps. And if you are a DBA, to understand that a developer has to get their feature out with or without you. So if you're going to be in their way, you're probably going to make a lot of heartache for yourself in the end. So try and find that healthy tension where you have some communication and some controls, but not so much that people curse your name every time they go to do a deploy. The other thing is, I mean, honestly, I interview DBAs all the time, and the number of times that I hear that DBAs have to do deploys makes me a little concerned, because as a DBA, you don't want your job to be just sitting there, especially if you're doing deploys 2 times a day. Your entire job is doing deploys, and you don't have time to look at your graphs, you don't have time to respond to those actionable alerts that you have going on, and you don't have time to be in front of the changes that developers are happening. So I'd rather be involved with planning and review, and then postmortems if something goes wrong, instead of trying to control the outcome in the moment. And if anyone has questions about that later, you can ask me about that some more. When you are building an infrastructure that you want to be at scale, hire DBAs that have experience with at scale infrastructures. That's what you can do with MySQL. It's not hard to find. Although, I'd like to get more people into the industry, so I don't want to say never hire inexperienced people. But I do think that a DBA who's got experience at scale can acknowledge that these challenges I just mentioned to you are different when you're talking about thousands of databases versus one. If I had one database, then yes, I would do every single deploy, and I would say, don't ever touch this database without talking to me. But when you have thousands of databases, there's no way you can do that. And I hope that more people actually move to that understanding of databases to work on more technologies for monitoring and sort of how to react quickly to it instead of preventing data disasters from ever happening. So speaking of just having one DBA, when I started at Twitter, we had one DBA, and there were a couple hundred databases. So that's how we've grown since 2010. We had versions all over the place. We couldn't do upgrades or take advantage of any features because we had single points of failure. It's something nobody likes to talk about, but I think everybody has. So at that time, we had a series of databases that were master-slave only. So writes went to a single master, reads went to a single slave, and we were vulnerable to a master database failing, right? So if you've got a hardware failure and the master database is down, now you can't send data to that database anymore. And it did happen. It didn't happen as much as you might think, but it did happen. We also didn't have the ability to load balance our slaves in using software or hardware load balancing. So we load balanced at the application layer. The major way that Twitter sharded in 2010 was something called temporal sharding. So basically, we've got a whole bunch of tweets, and the size of the data set for tweets was growing beyond. Let's say you've got like 2 terabytes of data available on one server. I don't know when it happened that we filled that much data, but once we moved that data, we needed to store more tweets in another shard. So what we did was essentially sharded based on when you tweeted. So the first 100 tweets would go in cluster 1, and then the next, and obviously I'm making up these numbers because we could store more than 100 tweets in one database, but the next 200, the next 100 are cluster 2. And so that's basically how we sharded based on the data set. So as we grew, we just kept rolling out these shards. There was another way that we needed to grow, which was in terms of I/O capacity and MySQL performance. And so that was how we basically scaled out within one cluster. So we might have 20 slaves in one cluster because we needed to serve all the tweets very quickly, the latest tweets. But the problem with that is your latest shard is the hottest shard, and your oldest shard is sitting around doing nothing. So you've got dozens of servers that are just holding your old tweets, and they're never getting accessed. It's expensive hardware. It's a RAID 10, 50, how many disks are we up to? Let's say 30 drives in RAID 10, and you've got like 20 of those machines sitting around for tweets that are almost never accessed. So that's really inefficient, it's costly, and then at the same time what was happening is our tweets were, this was in 2010, our tweets were growing at a rate that by the time DBA built enough servers for the next shard, it was time to start building another shard. So we realized that it was, and we only had one DBA, maybe 2 by that. So we realized that there would be a point at which humans could not keep up anymore with the rate of our tweets and building these additional shards. So fast forward, and then we saw the fail whale a lot. You guys all know that story. So fast forward to what we've got today. Through some pretty painful lessons, I just mentioned the idea that DBAs would have to be constantly building shards. That's what the situation was when we developed a technology called Gizzard that is on top of MySQL. We realized that we could no longer use our application layer sharding as it was, and so we needed to come up with something on top of MySQL that would allow us to replicate data without having to roll new master-slave clusters. Master-slaves were basically no longer a solution for Twitter. While I do think they are a solution for many other companies, at our scale it wasn't going to work anymore. So this next slide is Neil Armstrong passed away a couple months ago, and there was a visualization done by someone on our team of the tweets. These are all referencing Neil Armstrong in I don't know about in real time, but in time, as a demonstration of how quickly the tweets are moving across the world. Basically, as they were waking up, everyone was knowing that Neil Armstrong passed away. That level of real-time, tweets is not something we would have been able to do with our sharding capabilities in 2010. So today, where we're at is that MySQL is still the primary storage for Twitter. We also have a lot of peripheral services. So you probably don't think about it that much, but in Twitter, there's like a little navigation. There's a little panel that tells you who to follow. That's its own application service with its own data set. There's things around ads, things around revenue. There's a lot of applications that go into delivering the tweets that you are looking at outside of the tweets themselves. We're also multi-data center now. We weren't a few years ago. Plus 400 million tweets per day, and all the metadata, when you tweeted, who you tweeted to, all have to go somewhere. So again, MySQL is still our primary storage, but I'm going to talk to you about Gizzard now, which is actually the meat of what's unique about Twitter's use of MySQL. Gizzard is an open source project that Twitter built and maintains, so you guys can download it. It does need some work. So if you want to run it, I encourage you to, but definitely get back to us so we can talk to you about it. So it's a distributed data storage framework that's on top of a large number of MySQL databases. And Gizzard takes care of replication. So for every tweet that comes in, we're replicating it 4 times. So that's 400 million tweets per day replicated 4 times, stored across servers in multiple data centers, and also distributed across racks to help us with our failure domain. Gizzard right now is doing 6 million selects per second at peak. There are more than 3 billion new rows a day going into our Gizzard infrastructure, which I always have to look that up, sorry, because it changes constantly. Billion. Did you find, Jeremy made that mistake a couple weeks ago. Yeah, you got that. So 3 billion.
3 billion new rows.
New rows a day, yeah. So the cool thing about Gizzard is, so it's this application layer on top that's handling the distribution, but we get the stability and the tooling that we understand from MySQL without having to rely on MySQL replication. So we've taken out all of the replication settings for MySQL, and so, so it's faster. We're not worrying about some of the performance problems by writing to bin logs or anything like that. Gizzard, actually there's some applications that are on top of Gizzard, which are on top of MySQL, but just like MySQL is the building block for all of our storage, Gizzard's the building block for all of our distributed storage needs. So there are some technologies that still use master-slave clusters, but when we need to have that highly available high-performance solution, that's what we use with Gizzard. So Gizzard's handling the sharding based on ID, it's handling the replication, and then job scheduling. So I talked about it's an individually consistent data store. So Gizzard is the application that's keeping track of scheduling jobs to insert, delete, well, mostly insert and delete data into the MySQL databases. Like I said, it's open source, so feel free to download it. Flock database is on top of Gizzard. And has anyone already heard of Flock database by any chance? No? Okay, cool. So Flock database is an application, another application that's open source. So you can get all of these that I'm going to be talking about. You can get all of them from our open source repository. So Flock database is actually an application on top of Gizzard that stores the indexes of source ID to destination ID and counts counts the IDs per source ID. So essentially, it's the edge storage for ID to ID mapping. I mentioned earlier that MySQL works fine if it's just one-to-one, but when you have one-to-many, it becomes very costly, if not impossible, once you start talking about the relationships that Twitter have with its users. So we use FlockDB to store who are you following, who did you block, what lists of users you want to see. So basically, everything related to relationships between users and intersections between the users are in Flock database, which is on top of Gizzard, which is on top of MySQL.
But it's written in...
So the question is, what's FlockDB written in?
Yeah.
I don't actually know. That's a great question. I'll follow up.
I looked it up, and Gizzard's written in Scala. Which is new.
Yeah, the question is what it's written in. It's written in Scala, yeah.
I'll look it up.
So Scala is new as well, yeah. This is why we need to have more people using these tools, so it'll help us see how it's using. So there's definitely some challenges with these applications that are on top of MySQL, but to be honest, most of them have to do with operability. So what are the tools that we use to guarantee that we have the right number of copies per piece of data? How do you ensure that if a hardware fails, that all of that data is copied over to another host? That's all handled with Gizzard. But again, we're using Gizzard at this scale of thousands of servers. So Gizzard on just a few servers would be interesting to see. And they'll probably overkill. Also, FlockDB is pretty specific to how Twitter uses it, right? So unless you're building a social media app that also needs to understand the one-to-many, which you may be, it's not necessarily something that you're going to have to use. T-Bird is actually the application that stores tweets, which again, so the number one question people ask me is like, why does Twitter need a DBA? Because, I mean, tweets are just 140 characters. So it doesn't, it doesn't really, you know, they don't understand like, why do we have thousands of databases for just 140 character tweets? The answer is T-Bird, which actually just stores tweets, is very low velocity, and that's the least of our concerns. So like I said, the more interesting thing is how do you deliver tweets when Beyonce announces that she's pregnant on the VMA Awards to all of her followers instantaneously, and then also be able to handle their responses. So even though it may not be a lot of data for people to just tweet that Beyonce is pregnant, sending it to all of her followers and understanding who that is quickly is where we actually need to use Flock and T-Flock. So T-Bird, low velocity, it's basically just tweets and the small metadata for it. It's on top of MySQL, or Gizzard, which is on top of MySQL. T-Flock is, hold on one second. I'm having a technical issue here, sorry. Okay, I'm not able to see my notes for T-Flock. All right, we'll come back to that in a second. So earlier I mentioned that there's a challenge with user ID and auto increment. Has anyone been bitten by auto increment and user ID generation? Okay. Snowflake is basically what we use to generate unique sequential-esque IDs. So when we need to have, so for MySQL high availability, it's difficult if you're using auto increment for IDs to make sure that whatever ID you have is unique, because the two master servers may not be in communication with each other. So Snowflake allows us to do that. I'm running out of time, you guys, so I said I would do Q&A. Does anyone actually have questions? Oh, a couple of people, good. Okay, so we do still have 25 about master-slave clusters right now, and our older Rails application, of which there's very little left, still uses some of that older infrastructure. I would say it's still, I still get paged for that, so it's still like a service that's very important for Twitter. I don't want to like say that we're completely migrated to Gizzard. Also, like I said, you know, not every application needs to have Gizzard, so we still support the old model. We do have Cassandra, Hadoop, HDFS, Vertica, and other in-house storage technologies that have been written, and we use them for things that they're very good at. So Cassandra is sort of, gives us that high velocity with writes and sort of medium to low velocity with reads. So we use them for observability or for monitoring data. So things that we need to be able to sort of constantly log but not access very often is put on in Cassandra. Also, those are internal services, so it's not facing you. Hadoop and HDFS, great for storage of billions and billions of rows, like for example HTTP logs or application logs, and then we have an ability to process them on top of that storage. We can process them with Hadoop on top of HDFS. So Vertica is used for analytics. So again, analytics wants to like take all of our data and then just like multiply it with all of the jobs that our analytics teams want to do. And for them, they use Vertica. We have other in-house storage technologies being developed, and as we develop them, we open source them. We're also developing our own MySQL in-house, and this is not a fork of MySQL. It's just basically because we're iterating on MySQL so quickly, we can't always keep up. Sorry, Oracle's MySQL can't always keep up with us, so we have our own developer in-house. We develop, we've done things like add more status variables so that we get better monitoring from MySQL. We've done little things like with MySQL replication, we expire bin logs on something that's shorter than 1 day, and the stock MySQL can only do 1 day or day increments. Now you can do like 0.2 or just 1 hour. We also optimize for running on SSDs. We're mostly running on SSDs in our MySQL infrastructure. So MySQL is not optimized for that right now, but Twitter's MySQL is. And we're giving all of that back to the open source project. So hopefully these things are available for everyone else as well. Otherwise, you're welcome to download our MySQL binaries. In the future, we're working on real-time monitoring for MySQL. So right now we have per second or per minute even monitoring stats. We want to get to microseconds or do seconds really well. Most of the time, most monitoring is around minute or minutely averages, and we need to get down to seconds and microseconds because in a second even, or especially with a minute, we've missed an event with MySQL. So when we're troubleshooting, we need to be able to see what's happening in terms of microseconds because we may hit max connections or we may be hitting 100% CPU, but we're doing it in such a small period of time that our current monitoring tools are not able to catch it. Yeah, so we're also, like I said, we're open source. We have 91 projects in our open source repository. Twitter's open source repository, so check it out there. And Join the Flock is our recruiting Twitter address. So if you're interested in working for Twitter in any capacity, please let me know. Follow Join the Flock. I'm happy to give referrals and questions. No more questions? Actually, do you mind going up to the mic really quickly? Yeah, thanks.
Sorry, I was just curious about the Seattle office and the plans you guys have for that. How big is it and what sort of work is done there?
It's not very big right now. I think we have a dozen employees. Right now, we're all part of engineering teams that are based in San Francisco. The majority of engineering is San Francisco based. So how big it gets is still to be determined. I would like more coworkers in Seattle because I work here. Okay?
You mentioned a little bit about your growth historically. What kind of growth are you planning for the next couple of years? Is the velocity going to continue or increase?
Oh yeah, that wasn't a point I forgot to make earlier. There's no way for us to tell. That's actually where Twitter continues to grow, and they did, from the beginning at this sort of crazy, unstoppable pace. That when we do capacity projections, even looking at our past growth is not always helpful in determining what we're planning to grow at. We do know the rate at which we're growing, and so we tend to capacity project for like hardware purposes. But I'm not able to share those numbers with you. But let's just say that I don't see us slowing down. Also, we're growing hugely internationally. So that's another area where it's difficult to project, right? Because adoption in other countries is something that's happening right now. And like I said, the tweets per second record is actually from tweets from Japan. So that's obviously huge for us, yeah.
So you didn't talk about Memcache.
No, I didn't. I mentioned it at the beginning because I like it. Twitter actually has our own memcache called Twimemcache. I don't know how to pronounce it, but it's open source as well. There were some, so we use it all over the place. Like it's a vital part of our infrastructure, and it's in front of, I would say, all of our databases. And Rails, I'm not sure how many of you are familiar with Rails, but there's support natively for Memcache with Rails. There were some features that didn't exist at the time a couple of years ago in Memcache with the ability to change slab sizes and reallocate without destroying your entire cache, which was a performance problem for Twitter. So our Memcache has the ability to handle slab reallocation dynamically without throwing away your whole cache. Is there something more specific I can answer about Memcache? Okay. If it exists, we're using it. Yes.
Given all the experience you've had with MySQL, if someone hired you to go on to your next project and you were going to build something that you thought might have the scale of Twitter or plan around that, would you use MySQL, or would you investigate other options first?
Well, I think I would actually, yeah, I would totally start with MySQL. I'm not going to say something else. I would start with MySQL because I don't think that I'm going to be getting in trouble with MySQL until I've grown to such a size that I have other problems. And to be honest, like data storage, while it's important, when you're growing at the rate that Twitter is, it is actually one of the least things you should be concerned with. I mean, so here's the trade-off. You should be most concerned that your data is safe, and I feel comfortable with NODB that that part's true. And there are a lot of other technologies like Memcache or Redis or whatever other popular storage technology or caching technologies exist today to help with some of the performance concerns. Again, if it was just me, again, like first, I'm that person that's doing sysadmin and DBA and everything work, because that's usually what happens with new projects. I would use things that were well understood, well known, and use it as a building block. And then if there was something that MySQL wasn't able to do, I would look at some of the technologies around it. I've done a migration from Postgres to MySQL. It's not fun to do large migrations from one database technology to another. But because I'm so familiar with MySQL and I'm confident in the talent that's out there for these sort of world-class DBAs, you've got them at Facebook and Google and Twitter and other large companies that I completely can't think of right now. I know that I'm going to be able to hire the talent, and it doesn't take that long to come up to speed with MySQL either. I think that's the other thing. So when you're building a project, I guess I just don't think that that's a problem that hasn't already been solved. Even though it's not, I know it's not the sexiest answer. That's, you know, I think the #1 question I ask is why use something that's been freely available that anybody can just like download and get set up within a few minutes, and I think that's the answer. Mm-hmm. Any other questions? Okay. Thank you all. I'll hang out here for a few minutes. I think we're done. Yeah.